All right, cumulative review 3, number 7, determining the solutions. So this was just like problem 6, only you're not trying to find the extraneous, you're trying to find the actual solutions. So we got to isolate the absolute value, divide by 2 on both sides. We get this, and now we can make our 2 equations. Make the first equation straight up how you see it written, but without the bars. And then change all the signs for every term inside the bars, inside the absolute value. So that becomes positive x and positive 1. And solve. We get these 2 answers, -4 and positive 2. And then you just got to check them to see if they both work out. When we plug in the -4 for x and also plug in the 2 for x, both of them work out to be a true statement, so they are both solutions. Problem 8, find the inverse. Again, that's where we change this to a y and then switch your x and your y variables. And we get this. And we solve for y. And we come up with this answer, which we can actually change. Now, what I did was I changed this back to an inverse function expression, or inverse function notation. But what I did here, there's another way to write this. That x right there is technically a 1x, and so I really could make the fraction of 1 over -2 or -1/2. And then this is a -8 or a -8, and so -8 divided by -2 is +4. So that's 2 different ways to write the equation. We're never sure how they're going to present the answer choices, so you want to know how to kind of rewrite the answer choices in different ways. Okay, number 9. Cube. Cube is 3-dimensional. It's like a square, but 3-dimensional. So all the sides are the same measure. That means if one side is x plus 9, then they're all x plus 9. To find the volume of a cube, length times width times height. So you are just multiplying all of these together. My recommendation, go ahead and FOIL or distribute those last 2 expressions to come up with this trinomial. And then you can distribute that third expression to your new trinomial and get all these terms here. You just want to combine your like terms, your x squareds with x squareds, x's with x's. And we come up with this answer. All right, in problem 10, all right, we're subtracting the f of x function with the g of x function, but we got to plug in a 2 for the f of x, and we got to plug in a 1 for the g of x. So we plug that in here. First I set it up, put them both in parentheses, and then I plugged in my 2 and my 1 and got here. I worked out this first half and got an answer, worked out the second half, got an answer, and then I just subtracted the 2 answers to get 13. Number 11, finding the zeros. Guys, this is already in factored form. So to find the zeros, all I have to do is set each one of these expressions equal to 0 and just solve. Set this equal to 0 and solve, we get 5. Set this equal to 0 and solve, we get -1. Set this equal to 0 and solve, and we get 4/3. Those 3 answers are the 3 zeros. Or you could graph that in Desmos and see where it crosses the x-axis. Problem 12. To determine if an expression is a factor of another expression, you could just divide them. If it divides evenly, meaning that there is no remainder, then that means it is a factor. Because my x doesn't have a coefficient, I could use synthetic division here. Just remember to change that sign. Use -1. Sorry for the background noise, we got construction going on here. All right, and take each coefficient. Make sure you check for any placeholders. Let's see, I've got a coefficient for x to the 3rd, got one for x squared, got one for x, got a constant. I don't need any placeholders. There's no terms missing. And you use synthetic division. We did get a remainder, so that means that this is not a factor.